Appender in Log4j. Now we are focusing on Appender. Appenders are responsible for delivering log events to their destination. Every appender must implement the appender interface. Most appenders will extend abstract appender, which adds lifecycle and filterable support. Lifecycle allows components to finish initialization after configuration has completed and to perform cleanup during shutdown. Filterable allows the component to have filters attached to it, which are evaluated during event processing. Considering Log4j appenders, sustained throughput high is better. This is on Xeon CPU. This is Linux. Assuming which Log4j appender to use, assuming you selected Log4j2 as your login frameworks, next you may be interested in learning what performance trade-offs are selecting a specific Log4j2 configuration. For example, there are 3 appenders for logging to a file, random access file, and memory mapped file appenders. Which one should you use? If performance is all you care about, the graphs below shows your best choice is either the memory mapped appender, memory mapped file appender, or random access file appender. Some things to bear in mind: memory mapped file appender does not have a rolling variant yet. When the log file size exceeds memory mapped file region length, file needs to be remapped. This can be very expensive operation, taking several seconds if the region is large. Memory mapped file, the appender creates a pre-sized file from the beginning and fills it up gradually. This can be confused tool like tail. Many such tools don't work very well with the memory mapped file. On Windows, using tool like tail on file created by random access file appear can hold a lock on this file, which may prevent Log4j from opening a file again when the file application is restarted. In developing environment where you expect restart your application regularly, while using tool like tail to view the log file contents, the file appender may be reasonable trade-off between performance and flexibility. For production environment, performance may have higher priority. The graph here shows the sustainable throughput for console and file appenders in Log4j 2.6, and for reference also provide the Log4j 2.5 performance. It turns out that garbage-free text encoding logic in 2.6 gives these appenders a performance boost compared to Log4j 2.5. It is used to be the random access file appender was significantly faster. Especially in multi-threaded scenarios, but with 2.6 the release of file appender performance has improved and performance difference between these two appenders are similar. Another takeaway is just how much of performance drags logging in the console can be considered logging to a file and using tool like tail to watch the file change in real time. Here we are using here JDK 1.8.0 underscore 45 on RHEL 6.5, Linux 2.6.32 573.1.1 EL6 underscore x86 underscore 64 with 10 core Xeon CPU ES-2660 V3 at 2.6 GHz with hyper-threading switched on 20 virtual cores. Here you can see the message per second, and Here these are the thread 1, 2, 4, 8, 16, 32 and 64. This is console 2.5. Here sorry, console 2.5 here. And console 2.6 is here, and file 2.5 here, and file 2.6 is here, and memory mapped file 2.5 here, memory mapped file 2.6 is here, and random access file 2.5 is here, random access file 2.6 is here. Here you can see the Log4j 2 Appender sustain throughput in higher is better in Windows 7 Enterprise. Here on Windows the results are similar, but the random access file and memory mapped file appenders outperform the plain file appender. In multi-threaded scenarios, absolute numbers are higher in Windows, and we don't know why, but it looks like Windows handles the log contents better than Linux. The Log4j 2 Appender comparison results here they are obtained in the JMHR benchmark harness. Here you can see the GDK 1.8.0 underscore 60 on Windows 7 Enterprise SP1 64-bit dual 8-core Xeon CPU ES2650V2 at 2.60 GHz through 2 virtual cores. Here the messages per second, and here 1, 2, 4, 8, 16, 32, 64 threads. Here the console 2.5. Here the console 2.6. Here the file 2.5. Here the file 2.6, and here the memory mapped file 2.5. Here the memory mapped file 2.6, and random access file 2.5 here, and random access file 2.6 is here. We can consider interface appender. Appends log events. An appender can contain a layout if applicable, as well as an error handler. Typical appender implementations coordinate with an implementation of abstract manager to handle external resources such as streams, connections, and other shared state. As appenders are plugins, concrete implementations needed to be annotated with plugin and need to provide a static factory method annotated with plugin factory. This is in the package org.apache.login.log4j.co. As an example too, we can consider this code segment. Here you can consider here you can see interface appender component builder, the builder for constructing appender components. This is in the package org.apache.log4j.co.config.builder.api. Here with the configuration builder with a new appender string name and the string plugin name, this will returns a builder for creating appender component builder. With add attributes, it adds an boolean attribute. This is a key and this is value. With add here, adds a layout to the append component. Here the layout component builder as a parameter. Here in configuration builder is the method new layout returns a builder for creating layout. The string plugin here. Here the add attributes, add the boolean attributes. This is the key and again value here, the pattern. And this return the layout. Layout component builder. This method, the add method, adds a filter to the component. So it this is the filter component builder here as a parameter. Here the new filter method returns a builder for creating filters. This is a filter component builder, and this is the plugin name. This is on match filter.result.deny, and this is on what happened on mismatch filter.result.neutral, and this is the attributes. Adds attribute boolean attributes. It's a key and this is the value. This will add the appender configure that appender component builder to the configuration builder here. Here you can see in this code segment, this is a file appender. This is a file appender. This is in package org.apache.login.log4j.co.appender. In this code, this adds an appender and a new logger config using that appender to the current configuration. Here the create here the create appender. This is the string method. This is string file name, and then append, and this is the file name and path of the file, and this is true if the file should be appended to, false if it should be overwritten. Default is true here, and this is locking, true if the file should be locked, the default is false. This is name of the appender, and this is immediate flush, true if the content should be flushed on every write, false otherwise. This is ignore exceptions. If true, the default exceptions encountered when appending events are locked, otherwise they are propagated to the caller. Buffered IO, true if the IO should be buffered, false otherwise. Buffer size str, buffer size for the buffered IO. Layout, the layout used to format the event. and the filter, the filter if any to use, and advertise, true if the appender configuration should be advertised, false otherwise. Advertise URI, advertise URI which can be used to retrieve the file contents and the configuration. And this method is deprecated. You can use new builder method instead. The start method make the filters available for use, and this will add the appender, and this is appender appender reference. Here this create appender reference, this will create an appender reference. This is ref, the name of the appender, and this is the level 2 filter against, and this is the filters to use. And this is logger config, logger object that is created via configuration. And this is create logger here. This will create the logger here. And this is additivity. This is deprecated and use the create logger with boolean method here. And this is log level, and this is logger name. Include location, refs here, properties, configuration, and filter. This is add in the log configuration, add appender. This will add an appender to the logger config. This is appender and level and filter. This is add logger, and this is logger name and the logger config here. And this will update loggers in the context. Here you can see writer appender appends log events to a writer. This is in package org.apache.login.log4j.co.appender. So for any given writer, like a print writer, you tell log4j to append events to that writer by creating writer appender and updating the log4j configuration. This is create appender, creates a writer appender. This is the layout and filter the target writer, and this is follow. If this is name of the appender, and this is follow, and if true will follow the changes to the underlying output stream. Use false as a default here, and this is ignore. True, default exception encountered when appending events are logged, otherwise they are propagated to the caller. In the start, make the filter available for use, and this will add the appender, and this is updating the logger. This is a typical console appender configuration. As one might expect, the console appender writes its output to either system.out or system.in error, with system.out being the default target. The layout must be provided to format the log event. Here the parameter name, the name of the appender. This is the target string, either system underscore out or system underscore error. The default is system underscore out. File appender. The file appender is an output stream appender that writes to the file named in the file name parameter. File appender uses a file manager which extend output stream manager to actually perform the file I/O. The file appenders from different configurations cannot be shared. The file managers can be if the manager is accessible. For example, two web applications in a servlet container can have their own configuration and safely write to the same file if log4j is in a class loader that is common to both of them. Here the name is the name of the adapter, also the name of the appender, and here the file name, the name of the file to write to. If the file or any of its parent directories does not exist, they will be created. As an example 7, we can consider JDBC appender. The JDBC appender writes log files, writes log events to a relational database table. Using the standard JDBC. It can be configured to obtain JDBC connections using JNDI data source or a custom factory method. The JDBC appender configured with data source requires a JNDI support. So as of release 2.17.1, this appender will not function unless log4j2.enable JNDI JDBC equal true is configured as a system property or environment variable. Here the parameter name is required and the name of the appender. Here the table name required, the name of the database table to insert log events into. The nested element data source uses JNDI. Do not share this connection with other clients. And here the JNDI name is required and parameter. The full prefix JNDI name that javax.sql.data source is bound to, such as here. The data source must be backed by a connection pool, otherwise logging will be very slow. And you can see column name and each event timestamp, column name, pattern, etc. Now we are considering appending log events to writers and output streams programmatically in programmatic configuration. Given any writer, like a print writer, or you tell the log4j append events that writer by creating a writer append and updating the log4j configuration. The module writer append in package log.apache.login.log4j.co.append in module log.apache.login4log4j.co appends log events to a writer. Log4j 2.5 provides facilities to append log events to writers and output streams. For example, this provides simple integration for JDBC driver implementation that use Log4j internally and still want to support JDBC APIs. Common dataset data source set log writer print writer java.sql driver manager set log writer print writer and java.sql driver manager set log stream print stream. Given writer and print writer, you tell log4j to append events that the writer by creating writer append and updating configuration. You can achieve the same with an output and print stream. Different use of output stream append and output stream append instead of write append. Yeah. Now we are considering appenders. Every appender must implement the appender interface. Interface appender in package org.apache.login.log4j.co in module org.apache.login.log4j.co appends log events. An appender can contain a layout if applicable as well as an error handler. Typical append implementations coordinate with an implementation of abstract manager to handle external resources such as streams, connections, and other shared state. As appenders are plugins, concrete implementations need to be annotated with plugin and need to provide a static factory method annotated with plugin factory. Appenders are responsible for delivering log events to their destination. Every appender must implement the appender interface. Most appenders will extend abstract appender which add lifecycle and filterable support. Lifecycle allows component to finish initialization after configuration has completed and to perform cleanup during shutdown. Filterable allows the component to have filters attached to it which are evaluated during event processing. Appenders usually are not responsible for writing the event data to the target destination. The most cases delegate responsibility for formatting the event to a layout. Some appenders wrap other appenders there so that they can modify the log event, handle the failure in an appender, route the event to subordinate appender based on the advanced filter criteria, or provide similar functionality that does not directly format the event for VB. Appenders always have a name so that they can be referred as loggers. Now we are considering async appenders. In appenders, to override the full default blocking queue factory, specify the plugin inside the async element. The class async appender in package log4j.login.log4j.co.appender in module log.append.login.log4j.co appends to one or more appenders asynchronously. You can configure as an async appender with one or more appenders, and that an appender to append to it if the queue is null. The async appender does not allow a filter to be specified on the appender references. Async appender accepts references to other appenders and causes log events to be written to them on separate thread. Note that the exceptions while writing to those appenders will be hidden from the application. The async appender should be configured after the appenders it references to allow it to shut down properly. By default, the async appender uses java.util.concurrent.array blocking queue, which does not require any external libraries. Note that the multi-threaded application should exercise care when using appender, such as blocking queue is susceptible to log contention, and other tests showed performance may become worse when more threads are logging concurrently. Consider the using log-free async loggers for optimal performance. Here the parameter name string, name of the appender. Here the parameter name buffer size integer. Specify the maximum number of events that can be queued. The default is 1024. Note that when using the disruptor style blocking queue, this buffer size must be a power of 2. When application is logging faster than the underlying appender can keep up with for long enough time to fulfill the queue, the behavior is determined by the async queue full policy. Parameter name appender ref string. The name of the appenders to invoke asynchronously. Multiple appender ref element can be configured. There are also a few system properties that can be used to maintain application throughput even when the underlying appender cannot keep up with the logging rate and the queue is filled up. See the check the properties. Check the system properties log4j2.async queue full policy and log4j2 queue discard threshold. Typical async appender configuration might look like here. Oh, sorry. The starting in Log4j 2.7, the custom implementation of blocking queue or transfer queue for queue can be specified using blocking queue factory plugin. To override the default blocking queue factory, specify the plugin inside async element. So Log4j chips with following implementation: array blocking plugin name, arrow blocking queue, disruptor blocking queue, JCT tools blocking queue, and link transfer queue. Here, this the link transfer queue. This uses the Java. This uses the new in Java 7 implementation link transfer queue. Note that this queue does not use the buffer size configuration attribute from async appender, as link transfer queue does not support the maximum capacity. Now we are considering Cassandra Appender. Here is an example Cassandra Appender configuration. The Cassandra Appender writes its output to a Apache Cassandra database. The key space and table must be configured ahead of time, and the columns of that table are mapped in the configuration file. Each column can specify either string layout, that is a pattern layout, along with the optional conversion type, only conversion type org.apache. login.log4j.spi.thread context type, or log4j.login.log4j.spi.thread context stack to store the MDC or NDC in a map or list column respectively. A conversation type compatible with java.util.date will use the log event timestamp converted to that type. That is, for example, use java.util.date to fulfill timestamp column type in Cassandra. Here the parameter type name string, the name of the appender, parameter name cluster name string, name of the Cassandra cluster to connect to, parameter name key space string, name of the key space containing the table that log messages will be returned to, table string, name of the table to write log messages to, buffer size int, the number of log messages to buffer or batch before writing. The default is by default no buffering is done. Batch boolean, whether or not to batch statement to write log messages to Cassandra. By default this is false. Here's an example of Cassandra configuration. This example configuration uses this following schema. Now we are considering console appender. Typical console configuration might look like here. The class console appender in package org.apache.login.log4j.co.appender in module log.apache.login.log4j.co. Append log event to system.out or system.error using the layout specified by the user. The default target is system.out. As might expect, the console appender writes its output to either system.out or system.error, with system.out being the default target. The layout must be provided to format the log event. Here the parameter name string, the name of the appender, target string, the either system underscore out or system underscore error. The default is system underscore out. The typical configuration might look like here. Now we are considering failed or failover appender. A failover configuration might look like here. Class failover appender in package org.apache.login.log4j.co.appender in module log.apache.login.log4j.co. The failover appender will capture exceptions in an appender and then route events to events to a different appender. Hopefully it is obvious that the appender must be configured to not suppress exception for failover appender to work. The failover appender wraps a set of appenders. If the primary appender fails, the secondary appender will be tried in order until one succeed, or there are more secondaries to try. The failover appender parameters, the name string, name of the appender, primary string, and the name of the primary appender to use. The failover configuration might look like here. If it is primary is failing, then it try to this one. Now we are considering file appender. Here is a sample file configuration. Class file appender in package log.apache.login.log4j.co.appender in module log.apache.login.log4j.co. File appender. The file appender is an output stream appender that writes to file name in the file name parameter. The file append uses the file manager, which extends the output stream manager to actually perform the I/O. While file appenders from different configuration cannot be shared, the file managers can be if the manager is accessible. For example, two web applications in a servlet container can have their own configuration and safely write to the same file if log4j is in a class loader that is common to both of them. Parameter names, here the name string, the name of the append, parameter name, file name, string, the name of the file to write to. If the file or any of its directories do not exist, they will be created. Here is an example of file configuration. Now we are considering Flume Appender. A sample Flume Appender configuration that is configured with the primary and secondary agent. Primary and secondary agent compresses the body formats the body using RFC 5424 layout. This is an optional component supplied in a separate jar. Apache Flume is a distributed, reliable and available system for efficiently collecting, aggregating and moving large amount of log data from many different sources to a centralized data store. The Flume Appender takes log event and sends them to a Flume agent as serialized env element for consumption. Flume Appender supports 3 modes of operation. 1. It acts as a remote Flume client which sends the Flume event via Evro to a Flume agent configured with Evro source. 2. It can act as an embedded Flume agent where Flume events pass directly into the Flume for processing. Or 3. It can persist events to a local Berkeley DB data store and asynchronously send the event to Flume, similar to the embedded Flume agent but without most of the Flume dependencies. Usage as an embedded agent will cause the message to be directly passed to Flume channel and will then the control immediately return to the application. In interaction with remote agents will occur asynchronously. Setting the type attribute to embedded will force the use of embedded agent. In addition, configuration agents properties in the Appender configuration will cause the embedded agent to be used. Flume Appender parameters: name, string, the name of the appender, here the compress, the boolean when set to true, the message body will be compressed using gzip. A sample Flume Appender configuration that is configured with the primary and secondary agent compresses the body and the format the body using RFC 5424 layout. A sample Flume Appender configuration that is configured with the primary and secondary agent compresses the body, formats the body using RFC 5424 layout and passes the encrypted event to disk. Now we are considering JDBC appender. Here are a couple of sample configuration for the JDBC appender, as well as sample factory implementation that uses common pooling and common DBCP to pool database connections. As of Log4j 2.11.0, JDBC support has been moved from existing module Log4j-core to the new module Log4j-JDBC. The JDBC appender writes log events to the relational database table using standard JDBC. It can be configured to obtain JDBC connections using JNDI data source. Or custom factory method. Whichever approach you take, it must be backed by a connection pool. Otherwise, the login performance will suffer greatly. If the batch statements are supported by configured JDBC driver and the buffer size is configured configured to be positive number, then the log event will be batched. Note that the Log4j 2.8, as of Log4j 2.8, there are two ways to configure log event in column making. Original column config, and column mapping. Column mapping plugin that uses Log4j's built-in type conversion to allow for more data types. This is same plugin as the Cassandra appender. To get off the ground quickly during development, an alternative to using a connection source based on JNDI is to use the non-pooling driver manager connection source. This connection source uses JDBC connection string, username and password. Optionally, you can also use properties. Parameters, JDBC appender parameters. Name string required the name of the appender. Table name string required the name of the database table to insert log events into. Ignore exception, boolean, default is true, causing exception encountered while appending events to be internally logged and then ignored. Then it is set to false. Exception will be propagated to the caller instead. You must set this to false when wrapping this appender in a failover appender. When configuring JDBC appender, you must specify connection source implementation from the appender get JDBC connections. You must use exactly one of the nested element, data source, connection factory, driver manager, pooling driver, the parameter name JNDI name string required the full prefix JNDI name that Java X dot SQL dot data source is bound to, such as Java :/comp /env/jdbc /logging data source. The data source must be backed by the connection full, otherwise logging will be very slow. Parameter class required a full qualified class name of a class containing static factory method for obtaining JDBC connections. When configuring the JDBC appender, use the column elements to specify which columns in the table should be written to and how to write them. The JDBC append uses this information to formulate prepared statement. The JDBC append uses this information to formulate prepared statement to insert record within a SQL injection vulnerability. Without SQL injection vulnerability, the column parameters name string required the name of the database column. Is event timestamp boolean? Use this attribute to insert an event timestamp to this column, which should be a SQL date time. The value will be inserted as java.sql.types.timestamp. Either this attribute equal to true pattern or is event timestamp must be specified, not more than one of these. Pattern string, use this attribute to insert a value or values from the log event in this column using pattern layout pattern. Simply specify any legal pattern in this attribute. Either this attribute literal or is timestamp true must be specified, but no more than one of these. Here the column mapping parameters name string required name of the database column. Here is a couple sample configuration for JDBC Appender, as well as simple factory implementation that uses common pooling and common DBCP. To pool database connections. Now we are considering NoSQL Appender. The following example demonstrate how log events are persisted in NoSQL databases if presented in a JSON format. The class NoSQL Appender in package org.apache.log4j.co.append.NoSQL in module org.apache.login.log4j.co. This appender has writes logging events to a NoSQL database using configured NoSQL provider. It requires implementation of NoSQL object, NoSQL connection, and NoSQL provider to know how to write events to the chosen NoSQL database. NoSQL Appender writes log events to NoSQL database using an internal lightweight provider interface. Provider implementations currently exist for MongoDB and Apache CouchDB, and writing custom provider is quite simple. To specify which NoSQL provider to use by specifying appropriate configuration element within NoSQL element, the types currently supported are MongoDB and CouchDB. To create your own custom provider, read the Java doc for NoSQL provider, NoSQL connection, and NoSQL object classes, and the documentation about creating Log4j plugins. We recommend you to review the source code for the MongoDB and CouchDB providers as a guide for creating your own provider. The following example demonstrates how log events are persisted in NoSQL databases if represented in JSON format. SQL Appender MongoDB. We provide the following MongoDB modules added in 2.11.0. The Log4j-MongoDB3 defines the configuration element MongoDB3 matching the MongoDB driver version 3. Added in 2.14.0, Log4j-MongoDB4 defines the configuration element MongoDB4 matching the MongoDB driver version 4. We no longer provide modules Log4j-MongoDB and Log4j-MongoDB2. Now we are considering NoSQL Appender MongoDB3. Here are a few sample configuration for NoSQL Appender and MongoDB3 provider. Here we are considering NoSQL Appender provider for MongoDB using MongoDB drive version 3. The NoSQL Appender writes log events to a NoSQL database using internal lightweight provider interface. MongoDB3 provider parameters. Database name, string. If you do not specify the factory class name and factory method name for providing MongoDB connection, you must specify MongoDB database name using this attribute. You must also specify a username and password. You can optionally also specify a server default to localhost and a port defaults to a default MongoDB port. Collection size int. Collection size is not here. Sorry. Collection name is string. Required the name of the MongoDB collection to insert the events into. Server, String, this see the documentation for attribute database name. Username string, see the documentation for attribute database name and factory class name. Password string, see the documentation for attribute database name and factory class name. This appender is a map message aware. Here are some sample configuration for NoSQL appender and MongoDB provider. Here now we are considering MongoDB NoSQL appender MongoDB 4. Here are a few sample configuration for NoSQL appender MongoDB and MongoDB 4 provider. This here we are with the here we are specialization of the NoSQL appender provider for MongoDB using MongoDB driver version 4. The NoSQL appender writes log events to a NoSQL database using the internal lightweight provider interface. MongoDB 3 provider, MongoDB 3 provider parameters, connection, string, required MongoDB connection string in the format MongoDB : / username and password at host 1 and then port port 1 and then again host 2 if there are, and then port 2, etc. Then / then database, then collection. If there are option we can put it here. Here the capped type boolean enable support for capped collections. Here the collection size int, specify the size in bytes of the capped collection to use if enabled. The maximum size is 4096 byte, and the larger size will be the minimum size is 4096 byte, and the larger size will be increased to the nearest integer multiple of 256. See the capped collection documentation for more information. This append is a map message aware. Here are a few configurations for NoSQL appender and MongoDB 4 provider. Now we are considering NoSQL appender CouchDB. Here are a few sample configuration for NoSQL appender and the CouchDB provider. This section details specialization of NoSQL appender provider for CouchDB. The NoSQL appender writes the log events to the NoSQL database using the internal lightweight provider interface. CouchDB provider parameters: database name is string, type is string, and if you do not specify factory class name and factory method name for providing a CouchDB connection, you must specify a CouchDB database name using this attribute. You must also specify a username and password. You can optionally also specify protocol, default to HTTP, server default to localhost, and port default to 80 for HTTP and 443 for HTTPS. Protocol string must either be HTTP or HTTPS. See the documentation for attribute database name. Server string, see the documentation for attribute database name. Username string, see the documentation for attribute database name. Password string, see the documentation for attribute database name. Here are a few configurations for NoSQL Appender and CouchDB provider. Oh, sorry, it's there. And now we are considering output stream appender. The output stream appender provides the base for many of the other appender providers. Based on many other appenders such as file and socket appender that write the event to the database outstream. It cannot be directly configured. Support for immediate flush and buffering is provided by the output stream appender. The class output stream appender in package org.apache.mod login.log4j.co.appender in module log.apache.login.log4j.co appends log events to a given output stream using layout. The output stream appender uses output stream manager to handle the actual I/O, allowing stream to be shared by appenders in multiple configurations. Now we are considering random access file appender. Here is a sample random access file configuration. The class random access file appender in package org.apache.login.log4j.co.appender in module log.apache.login.log4j.co, the file appender. Random access file appender is similar to the standard file appender, except it is always buffered. This cannot be switched off, and internally it uses buffer plus random access file. Instead of buffered output stream, we saw 20 to 200% performance improvement compared to the file appender with buffered I/O equal true in our measurements. Similar to the file appender, random access file appender uses random access file manager to actually perform the file I/O. While random access file appender from different configuration cannot be shared, the random access file managers can be if the manager is accessible. For example, two web applications in a servlet container can have their own configuration and the safely write to the same file if Log4j is in a class loader that is common to both of them. Random access file append parameters. A name type is string, the name of the appender. File name type is string, the name of the file to write to. If the file or any of its parent directories do not exist, they will be created. Here is a simple random access file configuration. Now we are considering rewrite appender. The following configuration shows read appender configured to add a product key and its value to the map message. The class redirect appender in package log.apache.login.log4j.co.appender.rewrite in module log.apache.login.log4j.co. This appender allows the logging event to be manipulated before it is processed by other appenders. Rewrite appender allows the log event to manipulated before it's processed by the another appender. This can be used to mask sensitive information such as password or to inject information into each event. The redirect appender must be configured with the redirect policy. The redirect appender should be configured after any appenders it references to allow it to shut down properly. Parameter name appender redirect appender parameters appender f type string. The name of the appenders to call after the log event has been manipulated. Multiple appender f elements can be configured. The name string the name of the this is the parameter the name parameter name and the type string the name of the appender. Redirect policy is an interface that allows implementations to inspect and possibly modify log event before they are passed to appender. Redirect policy declares a single method named rewrite that must be implemented. The method is passed the log event then and can return the same event or create a new one. Map rewrite policy. The map rewrite policy will evaluate log events that contain a map message and will add or update elements of the map. So the parameter name mode type string add or update. The following configuration shows the rewrite appender configured to add product key and its value to the map message. Properties rewrite policy. The properties rewrite policy will add properties configured on the policy to the thread context map being logged. These properties the properties will not add to the actual context map. The policy property values may contain variable that will be evaluated when configuration process as well as the event is logged. The following configuration shows rewrite appender configured to add add some properties here. The logger name level rewrite policy. You can use this policy to make loggers in third party code less chatty by changing event levels. The logger name level rewrite policy will rewrite the log event levels for a given logger name prefix. You configure logger name level rewrite policy with the logger name prefix and a pairs of levels, where the pair defines a source level and a target level. Parameter name logger, type string, a logger name used as a prefix to test each event's logger name. This configuration shows a rewrite appender configured to map level info to debug and a level 1 to info for all loggers that start with com.foo.bar. Rolling file append archives are stored in a directory based on the current year and month. All files under the base directory that match the / app archives are stored in a directory based on the current year and month. All files are under the base directory that match the / app log4j glob and are 60 days old or older are deleted at rollover time. The class rolling file appender in package org.apache.login.log4j.co.appender in module org.apache.login.log4j.co, an appender that writes to files and can roll over at intervals. The rolling file append is an output stream appender that writes to the file named in the file name parameter and the rolls the file over according to the triggering policy and the rollover policy. The rolling file append uses rolling file manager which extend the output stream manager to actually perform the file IO and perform the rollover. While rollover file appenders from different configuration cannot be shared, the rolling file managers can be if the manager is accessible. For example, two web applications in a servlet container can have their own configuration and safely write to the same file if the log4j is in the class loader that is common to both of them. Rolling file append requires a triggering policy and rollover strategy. Triggering policy determines if a rollover should be performed, while the rollover strategy defines how the rollover should be done. If no rollover strategy is configured, the rolling file appender uses default rollover strategy. Since the Log4j-2.5, a custom delete action can be configured in the rollover strategy. to run at rollover. Since 2.8, if no file name is configured, then the direct write rollover strategy will be used instead of default rollover strategy. Since log4j-2.9, the custom POSIX file attribute view action view action can be configured in the default rollover strategy to run at rollover if not defined. Inherited POSIX file attribute view from the rolling file appender will be applied. File locking is not supported by the rolling file appender. Rolling file appender parameters: name, string, the name of the appender, file name, string, the name of the file to write to. If the file or any of its parameter directories do not exist, they will be created. File pattern, string, the pattern of the file name of the archived log file. The format of the pattern is dependent on the rollover policy that is used. The default rollover policy will accept both the date or pattern compatible simple date format or which represent an integer counter. Integer counter allows specifying a padding like %3i for space padding for counter to 3 digits, usually more powerful %03y for 0 padding the counter 3 to 2 digits. The pattern also support interpolation at runtime, so that any of the lookup such as date lookup can be included in the pattern. With triggering policies, composite triggering policy. The composite triggering policy combines multiple triggering policies, then returns true if any of the configured policies return true. The cron triggering policy triggers rollover based on the cron expression. If the policy is controlled by a timer and is asynchronous to process log events, so it is possible that the log events from the previous or next time period may be appear at the beginning or end of the log file. The file pattern attribute of the appender should contain timestamp, otherwise the target file will be overwritten on each rollover. The cron triggering policy parameters: schedule is a string, cron expression. The cron expressions is the same as what is allowed in the parts scheduler. See the cron expression for a full description of the expression. On startup, this on startup triggering policy. On startup trigger policy causes a rollover if the log files is older than the current JVM start time and the minimum file size is met or exceeded. There's a size-based triggering policy also, and the time-based triggering policy. The time-based triggering policy causes rollover once the date and time pattern this is size-based triggering policy. The size-based triggering policy causes rollover once the file has reached the specific size. The size can be specified in bytes with the suffix KB, MB, GB, or TB. The time-based triggering policy. The time-based triggering policy causes rollover once the date or time pattern no longer applied to achieve file. rollover strategy is a default rollover strategy. The default rollover strategy accepts both date and time pattern and an integer from the file pattern attribute is specified on the rolling file append itself. If the date and time pattern is present, it will be replaced with the time with the current date and time values. If the pattern contains an integer, it will be incremented uh, uh, incremented on each rollover. If the pattern contains both date and time, an integer pattern in the integer will be incremented until the result of the date and time date or time pattern changes. If the file pattern ends with the .gzip gzip or gz2 .deflate.pack.200 or .xz, the resulting archive will be compressed using the compression scheme that matches the suffix. The format bzip2 deflate pack 2000 and put pack 200 and xz require Apache command compress. In addition, xz required exists for Java. The pattern may also contain lookup references that can be resolved at runtime, such as is shown in this example. There's another direct write rollover strategy. And custom delete on rollover. Delete if file name. The parameter name, if file name condition parameters, the parameter name glob, it is string, required if the regress is not specified, matches the relative path relative to the base path using the limited pattern language that resemble the regular expression but with the simpler syntax. Delete sorry, this is delete, we're talking about delete if file name. Below is a simple sample configuration that uses a rolling file appender with the cron triggering policy configured to trigger every day at midnight. Archives are stored in a directory based on the current year and month. All files under the base directory that matches the app dash then .log4j glob and 60 days old or older are deleted at rollover time. Here is an example sample configuration that uses rolling file appender with both the time and the size based triggering policies. We'll create up to 100 archives. Yeah, here 100 archives on same day. Um, 1 to 100 that are stored in a directory based on the current year and the month. Year and we'll compress each archive using gzip and we'll roll over every hour. During every rollover, this configuration will delete files that match /app -log.gz and are 30 days old, 30 days older, but keep the most recent 100 GB or most recent 10 files, whichever comes first. Nested condition timer, the inner condition is only evaluated on files for which the outer conditions are true. The class rolling file appender package in package log4j.login.log4j.co.appender in module log4j.login.log4j.co, and appender that writes to files and can roll over at intervals. Now we are considering rolling random access file appender. Below here is a simple sample configuration that uses rolling random file appender with both time and size based triggering policies. Will create up to 7 archives on the same day, 1 to 7, that are stored in the directory based on the current year and the month, and we'll compress each archive using gzip. The rolling random access file appender is similar to the standard rolling file appender, except it is always buffered with this cannot be switched off, and Intel uses buffer plus random access file instead of buffer output file string. We saw 20 to 200% performance improvement compared to the rolling appender with buffered IO equal true with in our measurements. Rolling random access file appender writes to the file named in the file name appender and rolls the file over according the triggering policy and the rolling policy. Similar to the rolling file appender, the rolling file random access file appender uses rolling random access file manager to actually perform the IO and perform the rollover. By rolling random access file appender from the different configuration cannot be shared, the rolling random access file managers can be if the managers are accessible. For example, two web application in a servlet container can have their own configuration and safely write to the same file if the log4j is in a class loader that is common to both of them. A rolling file A rolling random file access file appender requires triggering policy and rollover strategy. Uh, the triggering policy determines if the rollover should be performed the triggering policy determines if the rollover be performed, while the rollover strategy defines how the rollover should be done. If no rollover strategy is configured, rolling random access file appender will use the default rolling strategy. Since Log4j 2.5, the custom delete action can be configured in the default rolling strategy to run at the rollover. File locking is not supported by the rolling and random access file appender. The rolling random access file appender parameters: the string name of the appender, file name string, the name of the file to write to if the file or any of these parent directories do not exist, they will be created. File pattern string, the pattern of the file name of the archiving log file. The format of the pattern should is dependent on the rollover that is used. The default rollover policy will accept both date and time. Pattern compatible with the simple date format or in $i, which represent the integer counter. The pattern also supports interpolation at runtime, so any of the lookups such as date lookup can be included in the pattern. See the class rolling random access file appender in package log4j.code appender in module log4j.login.log4j.co, an appender that writes random access files and can roll over at intervals. Here is a sample configuration that uses rolling random access file appender with both time and size based triggering policies. Will create up to 7 archives, and time and size triggering policy and approve archives on the same day 1 to 7 that is stored in a directory based on the current year and the month, and will compress each archive using gzip. This example here the shows a rollover strategy that is the rollover strategy that keep 20 files before removing them. Now we are considering routing appender. In this example, the script uses service windows root to be default, root on the Windows, and service other on all other operating systems. Note that the list appender is one of our test appenders. Any appender can be used if it is only used as an shorthand. The class routing appender in the API, the package org.apache.login.log4j.co.appender.routing in module org.apache.login.log4j.co. This appender routes between various appenders, some of which can be references to appenders defined earlier in the configuration, while others can be dynamically created within this appender as required. Routing is achieved by specifying a pattern on the routing appender declaration. The pattern should contain one or more substituting patterns of the form $ key and then token. The pattern will be resolved each time the append is called using the built-in str substitutor. And str lookup file lookup matches the specific key. The routing append evaluates log events and you then route them to a subnet appender. The target appender may be an append previously configured and may be referenced by its name, and the appender can be dynamically created as needed. The routing appender should be configured after any appenders it references to allow it to shut down properly. You can also configure a routing appender with scripts. You can run a script when appender start and when the route is chosen for a log event. The routing appender parameters, name, type string, and name of the appender. In this example, the script causes service windows route to be default route on the Windows and service other route on all other operating systems. Note that the list appender is one of our test appenders. Any appender can be used. It is only used as a shorthand. The roots elements here accept a single attribute named pattern. The pattern is evaluated against all the registered lookups and the result is used to select the root. Each root may be configured with the key. If the key matches the result of the evaluation result of the evaluation pattern, then that route will be selected. If no key is specified on the route, then the route is the default. Only one route can be configured as default. You can also include the purge policy. The routing appender can be configured with the purge policy whose support is to stop and remove dormant appenders that have been dynamically created by the routing appender. Now we are considering SMTP appenders. As with other appenders, the formatting can be controlled by specifying a layout for the appender. SMTP appender as of log 2.11.0, the simple mail transfer protocol SMTP support has moved to the existing module log4j-core to the new module log4j-smtp. Send an email when a specific logging event occurs typically on errors or fatal errors. The number of logging events delivered to this email depend on the value of the buffer size option. The SMTP appender keeps only the last buffer size logging events in the cyclic buffer. This keeps the memory requirements at a reasonable level while still delivering useful application context. All events in the buffer are included in the email. The buffer will contain the most recent event of the level trace or test one proceeding that the event triggered the email. The default behavior is to trigger sending an email whenever error or higher severity event is logged, and to format it as HTML. The circumstances on when the email is sent to be controlled by setting one or more filters on the appender. As with the other appender, the formatting can be controlled by specifying a layout for the appender. The SMTP appender parameters name, the type is string and name of the appender, subject type is string, then subject of the mail message. 2, this type is string and the comma separated list of the recipient email address. From the string, the email address of the sender. SMTP host, the string SMTP host name to send to. This parameter is required. SMTP port integer, SMTP port to send to. Buffer size 50. Buffer size the integer, the maximum number of log events to be buffered for inclusion in the message. Default to 512. Now we are considering script appender selector. The script appender selector, the appender name is recorded under the name of the script appender selector, not the name of the selected appender. In this example, select it. When the configuration is built, the scripts appender selector appender calls script plugin to compute the appender name. The Log4j then creates one of the appender names listed under the appender set using the name of the script appender selector. After configuration, the Log4j ignores the script appender selector. Log4j only builds the one selected appender from the configuration tree. And ignores after appender set child nodes. In this example, the script returns the name script return the name, the list 2, and the appender name is recorded under the name of the script appender selector. not the name of the selected appender. In this example, select it. Or one of this one or other one. Now we are considering socket appender. This is an unsecured TCP configuration. The class socket appender in package log4j.login.log4j.core.appender in module log4j.login.log4j.core, an appender that delivers events over socket connections, support both TCP and UDP. The socket appender is an output stream appender that writes its output to a remote destination specified by a host and a port. The data can be sent over either TCP or UDP and can be sent in any format. You can optionally secure the communication with SSL. Note that the TCP and SSL variant writes the socket as an stream and do not expect response from target destination. Due to the limitation of TCP protocol, that means that when the target server closes this connection, some log events may continue to appear to succeed until a close connection exception is raised, causing those events to be lost. If the guaranteed delivery is required in a protocol, that required acknowledgement must be used. Socket appender parameters: name, string, name of the appender; host, string, name of the address of the system that is listening for log events. The parameter is required. Port, integer, the port of the host that is listening for log event. This parameter must be specified. If the host name resolve to multiple IP addresses, TCP and SSL variant will fail over the next IP address when the connection is lost. This is an unsecured TCP connection. This is a secured SSL configuration. Sorry, this is an unsecured TCP configuration, and this is a secured SSL configuration. This is an now we are considering SSL. This is an example. Package log4j.log4j.core.net.SSL in module log4j.login.log4j.core in log4j to SSL support. The several appenders can be configured to used either in plain network connection or a secure socket layer SSL connection. This connection. This section, here now we document the SSL connection. The SSL configuration parameters: keystore, type keystore contains the primary keystore and contains the primary keys and certificate, and determine which authentication credentials to send to the remote host. Trust store contains the CA certificate of the remote counterparty, determines whether the remote authentication credentials and thus connection should be trusted. The key store is meant to contain private keys and certificates, and determines which authentication credentials to send to the remote host. Key store configuration parameters: location, type string, path to the key store file, password environment variable string, name of the environment variable holds the password, cannot be combined with either password or password file. Trusted store, the trusted store is meant to contain CA certificate you are willing to trust. When a remote party presents its certificate, determines whether the remote authentication credentials and thus the connection should be trusted. In some cases, they can be one and same store, although it is often better practice to use distinct store, especially when they are file based. Trusted store configuration parameters, location, the string, path to key store file, parameter name, password file, type string, the path to the file that hold the password cannot be combined with either password or password environment variable. This is an example here. Now we are considering syslog append. A sample syslog append configuration that is configured with two syslog appenders, one using BSD format and one using RFC 5424 format. The class syslog appender in package login.log4j.co.appender in module log4j.login.log4j.co. The syslog appender. The syslog appender is a socket appender that writes its output to a remote destination specified by the host and the port in a format that confirm with either BSD or BSD syslog format or RFC 5424 format. The data can be sent over either TCP or UDP. Syslog appender parameters, name, type string and name of the appender, host, type string and the name of or address of the system that is listening for log events. This parameter is required. Port, integer, port on the host that is listening for log events. This parameter must be specified. Protocol, type string and UDP or TCP or UDP. This parameter is required. A sample syslog appender configuration that is configured with two syslog appenders, one for BSD and another one for RFC 5424. This is here's an for SSL. This appender writes the output to a remote destination is specified by the host and the port over SSL in a format that confirm either BSD syslog format or RFC 5424 format. Now we are considering JROMQ appender. This is a simple JROMQ configuration. As of Log4j 2.11.0, JROMQ and ZeroMQ and JROMQ or JROMQ support has moved from existing module Log4j-core to the new module Log4j-JROMQ. The ZeroMQ appender uses JROMQ library to send log event to one or more ZeroMQ endpoints. This is a sample JROMQ configuration. JROMQ parameters. A name, a string, name of the appender required. Now we are considering here the module package org.apache.login.log4j.core.append in module log.apache.login.log4j.core log4j2 appenders. Now we are considering log4j JDBC connection source with Apache Commons DBCP2. This module adds a connection source for JDBC appenders. The pooling driver connection source provides connection pooling through Apache Commons DBCP2. With the requirements, this module was introduced in Log4j. With regard, we are considering Apache Commons DBCP2. This module is introduced in Log4j 2.11.0 and requires Apache Commons DBCP2 to provide connection pooling. Some features may require optional dependencies. These dependencies are specified in the documentation for those features. Some Log4j features required external dependencies. See the dependency tree for the exact list of jar files needed for these features. Now we are considering Apache Log4j ZeroMQ using JROMQ module. As of Log4j 2.11.0, ZeroMQ using JROMQ support has been moved from existing module to module core Log4j-core to new module Log4j-JROMQ. Now we're considering a requirement in Apache Log4j JROMQ using JROMQ module. This module was introduced in Log4j 2.11.0 and requires a JROMQ jar. Some features may require optional dependencies. These dependencies are specified in documentation for those features. Some Log4j features require external dependencies. Now we are considering Flume Appender, the remote agent in Flume Appender. The Flume Appender allows application to send event to Flume agents, including Log4j Flume ng jar in your Maven-based project, as a dependency should cause all the transitive dependency necessary for the remote agent to function to be included. Now we're considering persistent agent. The persistent agent uses Barclay DB. The following dependency should be added to your pom.xml in addition to the log4j-flume.ng dependency. The following now we are considering embedded agent. The following is a sample POM file for Maven that can be used as a template for integrating the Flume embedded appender into the application. Log4j2 API, Log4j2 Log4j 1.x API, Log4j2 implementation, SLF4j SLF4j2 Log4j2 binding, SLF4j API, SLF4j extensions, common logging to Log4j to binding, Euro transport protocol required for Flume, hardcore Hadoop core required by embedded Flume agent, Flume file channel required by embedded Flume agent. The requirements: the Flume appender requires Log4j2 API. Apache Log4j Java message service JMS module. As of Log4j 2.11.0, JMS support has been moved from existing module Log4j core to the new module Log4j-JMS. A requirement: this module was introduced in Log4j 2.11.0 and required a JMS API jar. Some features may require optional dependencies. Some Log4j features require external dependencies. Now we are considering CouchDB append. The CouchDB append, the Apache CouchDB is support through light couch driver. Requirement: the CouchDB append is dependent on the Log4j2 API and implementation. The MongoDB append, the MongoDB is supported through MongoDB driver. The requirements: the MongoDB append is dependent on the Log4j2 API and implementation. MongoDB Appender. The MongoDB is supported through MongoDB Java MongoDB driver. The requirements: the MongoDB append is dependent on the Log4j 2 API and implementation. Cassandra Appender. The Cassandra Appender allows application to send events to Apache Cassandra repositories. Now we are considering Apache Flume Appender in Maven, IV, Gradle, and SBT certificates. The Flume Appender allows applications to send events to Flume agents. Here the pom.xml here, and here the iv.xml, and here build.gradle.xml, and here build.sbt. This is iv.xml. Here the build.gradle. Here the build.sbt. If your configuration uses NoSQL CouchDB appender, then add the following here. This is pom.xml, and this is iv.xml. Here the build.gradle. Here the build.sbt. Cassandra, if your configuration uses Cassandra appender, then add the following. This is build pom.xml. Here the iv.xml. Here the gradle build.gradle, and here the build.sbt. Now we are considering supported appenders in supported components in Log4j 2 compatibility with Log4j 1, async appender, console appender, daily rolling file appender, null appender, rewrite appender, limited rolling file appender, and syslog appender. Here now we are considering configuring simple configuration using console appender in configure Log4j 2 and from migrating from Log4j 1.x. Here the Log4j 1.x XML configuration here. This is log4j.xml. This is log4j 2 XML configuration, log4j 2.xml. Now we are considering simple configuration using file appender. XML layout and simple layout. This is log4j 1.x XML configuration. Log4j.xml. This is Log4j 2 XML configuration. Now we're considering socket appender, the Log4j 1.x XML configuration. This example Log4j 1.x is misleading. The socket appender does not actually use a layout. Configuring one will have no effect. Log4j .xml, this one. Log4j 2.xml configuration, Log4j 2.xml. Here async appender and you consider now async appender TTCC layout. Here the Log4j 1.x XML configuration using async appender. This is Log4j XML, Log4j.xml. The XML Log4j 2 XML configuration, Log4j 2.xml. Now we are considering async append with console and file. Log4j 1.x XML configuration using async append here. The Log4j.xml. Now we are considering configuring appenders in configuration. An append is configured either using specific appender plugin name or with an appender element and appender type and the type attribute contained in the appender plugin's name. In addition, each appender must have a name attribute specified with a value that is unique with that set of appenders. The name will be used by loggers to reference the appender as described in the previous section. Most appenders also support a layout to be configured, which again may be specified either using specific layout plugin's name as the element or with layout as the element name along with the type attribute that contains the layout plugin's name. The various appenders will contain other attributes or elements that are required for them to function properly. Here we are considering using the servlet appender in web applications and JSPs. For example, here The Log4j provides a servlet append that uses the servlet context as a log target. For example, this here, to avoid double logging of exceptions to the servlet context, you must use this part percentage sign ex none here in your pattern layout. As shown in this example, the exception will be omitted from the message text, but it is passed to the servlet context as an actual throwable object. Now we are considering supported appenders in garbage-free steady logging. The following appenders are garbage-free during steady-state logging: console file, rolling file. Some temporary objects are created during file rollover. Random access file, rolling random access file. Some temporary objects are created during the file rollover. Memory mapped file. Any other appenders not in the above list, including async appender, create temporary objects during steady state logging. Instead of async appender, use async loggers to log asynchronously in a garbage free manner. Now we are considering appenders in extending Log4j 3. This ensures that the events are not lost while the configuration of taking place without requiring that logging pause while reconfiguration takes place. Class abstract output stream appender, m extends output stream appender. In package log4j.log4j.core.append, in module log4j.log4j.core appends log events to a byte-to-byte output stream. The stream encoding is defined in the layout. The appenders are passed an event, usually invoke a layout to format the event, then and then publish the event in whatever manner it is desired. Appenders are declared as at configurable and with an element type of append. The value attribute at plugin annotation specifies the name of the element users must provide in the configuration to use the appender. Appender should specify print object as true if the toString method renders the values of the attribute passed to the appender. Appenders must also declare at plugin factory method that returns an instance of appender or a builder class used to create appenders. The example here shows the appender name stub. That can be used as an initial template. Most appenders use managers. A manager usually owns a resource such as output stream. When a reconfiguration occurs, a new appender will be created. However, if nothing significant in the previous manager has changed, the new appender will simply reference it instead of creating new one. This ensures that the events are not lost while reconfiguration taking place without requiring a logging pause while reconfiguration take place. Example, we can consider appender logging exception, class appender logging exception, thrown from an appender when a log event could not be written. Appender should not throw an exception if an error occurs that does not stop the event from being successfully written. Those type of errors should be logged using the status logger. Appender should only throw exceptions when an error prevents an event from being written. Appenders must throw an exception in this case so that error handling features like the failover appender work properly. We can, as an error example, we can consider this occurred in the environment with Tomcat. Error could not find the value for key.log4j.appender.error, could not instantiate the appender name error, could not find the value for log4 j.appender.error and could not instantiate appender.error. No appenders could be found for logger, etc.